Hello guys, welcome back to my channel in Algorithm Minds, and this is where I teach you about topics related to data science programming. And today's tutorial I will teach you how to generate random numbers in Python. It's a quite simple task, but this tool is used extensively when you want to actually test your scripts or even a snippet of code. You just generate a random set of data and then evaluate your method. So I will go step by step and I will teach you everything about how to generate random numbers, and also like how to generate a matrix of order P and Q that has some random values. So let's start with the first step. The first one is actually quite basic. Like we first of all we import the necessary libraries. In our case, we are going to import the library NumPy, and then we are also going to import module random, which is pre-built in Python. Then finally we will also import matplotlib and its module pyplot, just to see and visualize how this randomly distributed data has been generated. So these like three libraries and modules we are going to import. The second thing we want to set is to use this line of code here, like np random.seed42. So most of you like have used it, or like you might be wondering why we use it, what does it mean. So basically it means that whenever this script is run, you will get the same sequence of randomly distributed number, irrespective the script is run on your computer or any other computer. It has been run multiple times. So, and the reason why we do this, and this is quite a good practice in like data science and machine learning, is because we have like actually develop a method like machine learning algorithm based on some random numbers for initially, and we have some sequence of data. Now we don't want to change the results of our machine learning algorithm, so we want to make sure that every time the script runs we get the same randomly distributed sequence. So in this case, this random seed42 comes in handy. It will like give us the idea, and it will also help us like generate the same sequence irrespective of the script, how many times the script has been run. So you now get the idea of this command here. So let's get started and just generate our first random number. In order to generate random number, we will use our library NumPy, and then we will call the module and function rand here, rand, random.rand, in the curly braces, and we will later on we will like pass some more additional arguments to this function here, but right now we are interested to just generate one value. So basically this syntax here, you see that it actually generates a random value between 0 and 1, and keep that in mind, the 0 is an exclusive, and 1 is exclusive. That means it will be always less than 1, and it might be equal to 0 or greater than 0. So if you run this, you see that we have a value of 0.3745, which is again a randomly distributed number, which is greater than 0 and less than 1. So this is how you actually create a single random value. But I know most of you people are interested, we want to generate a sequence of random values. So we are going to do that in this next block. So before like we actually generate those random numbers, let me give you a brief concept about mean and standard deviation in a distribution. In our case, our distribution is our data. So mean actually it represents like what is the average value of the data, like where the means lies, and standard deviation is like okay, how our data is deviating from the mean value. So we have like mean here and standard here. Most of the time when we are doing an analysis, we are interested, like we want to generate a specific randomly distributed sequence that has a mean of this value and a standard deviation of this value. So that's come in handy in many statistical tests also. So for that purpose, first of all, we will declare a variable. It could be anything, xyz. So we have in our case like random numbers with mean and standard deviation. Then we call the same function we have called earlier, np random normal, and we have like braces, and within the braces we will pass three arguments. I will discuss the three arguments. The first argument will be the mean. what will the mean of normally distributed sequence. The second one is standard deviation, and the third one is actually define the size. Okay, how many numbers we actually wanted. So in our case, I put size is equal to 5. So if you see that here, when we run it, we see that okay, our mean is 10 and our deviation is 2, and we get 5 number of sequence. And that sequence, if you see, like we have a mean of 10 and a standard deviation of 2. So it means that the distribution we are going to get will deviate between like above 10 or below 10 with the standard deviation of 2. So you can actually see that here. So this is the thing, like, but if, like, for example, let us change this value. Let's say we want to change the value of mean to 5, and standard deviation is equal to 2. We keep it same as here. So if I run it again, now you see that the mean is actually 5, because majority of values we are getting are quite close to 5, and like there are some values that are like 7. There are some values that are close to 3, for example 2.77. So that's how you actually generate a specific random distribution with specific mean and standard deviation. So okay, we have discussed about arrays and with sequence of numbers. Let's now discuss about randomly distributed matrix. Okay, we want to generate a matrix that has a random numbers in it, and we can use that matrix for specific purpose. For example, we can set it as a feature of our data set and anything. So it is quite simple. What we will do, we will first define the rows and column. Here P actually represents the rows here, and the Q represents columns. So here we define, okay, we want 2 rows and we want 3 columns, and we will use the same function here, np random rand, and then we pass the input argument rows and column. So we have P and Q, and once we run that, you see that we are now getting 2 rows and 3 columns, and these all values are somewhere between 0 and 1. So let's say you are more interested in, okay, I want like say 5 rows. So when I run it, now you see that we have like now 5 rows and 3 columns. So this is how you actually generate a matrix of P and Q order using random rand function of numpy. Okay, now we have distributed, like generated the data. Now let's have some fun with the data visualization. We want to see how this randomly distributed data has been generated. And if you want to have more in-depth tutorial about how to generate histograms, I have another video. You can check the link in my description. So I will share the link in the description for you. So we have like the sample size is equal to 1000, and this sample size here 1000 is same as like we have defined here size. So we have like 1000 numbers that are randomly distributed. Then we want like, okay, we want mean is equal to 10 and we want standard deviation is equal to 2, and like we have like generated set of random values here using this function here. Now we are going to plot the histogram, and for the plotting histogram we are going to use the function hist from matplotlib, and we will first pass the data, then we define the bins, the range. We want to actually group those data points, and then finally some aesthetic here, like we want the color to be blue and edge color to be black, and then some finally labeling like title, X label, Y label, and grid, and then finally we'll use function show to actually plot our histogram. So this is how actually the data looks in histogram. If you know, the frequency is the number of data point occurring within that specific range. So let's just change this value. Like say I'm more interested in changing the value of mean to 5 and the standard deviation to be 3. So if I run it, now you see that now we have a mean of 5 and a standard deviation of 3, and the data is quite close to mean 5 and the standard deviation of with respect to 3. So this is the whole idea of generating random numbers in Python. And thank you for joining me, and in the future tutorial I will be posting more videos about Python, R, so you can take advantage of. So stay tuned. Thank you for joining.